Oh, I didn't even connect. Oh, sorry. I realized I didn't even connect my earphones. All right, welcome to third week of workshops. So this is the end product of our workshop today, right? So we will be able to shoot some arrows, have some weapons, right? Have some enemies that moves around randomly, and we can, lots of events happening. We can shoot arrows to the ground and which will disappear after a few seconds. Yeah, so again, this is an interactive workshop. So just follow my demo and there will be many hands-on activities for this workshop, which you can try. Okay, let's go. So the first thing I'm going to talk about is collision, right? So remember last time we used this another function called move and slide to handle player movement, right? So actually for character body 2D, there is another function called move and collide, right? So I will demonstrate how to use this function. Okay, let's all open Godot. And right, I have imported the skeleton. So our first task will be creating a skeleton scene, right? As you can see from my demo just now, the skeleton should be able to move around and then turn back when it hits a wall, right? So let's just create the scene first and think about how to handle that collision later. Okay, so the skeleton should be a character body 2D. Character body 2D, right? Let's just rename it as skeleton. Right, and as usual, we will add a sprite 2D and a collision shape. Oh no. Collision shape 2D. Okay. So let's drag the skeleton into the sprite 2D and change the collision shape. Maybe let's say a rectangle. Okay. Okay. Let's save it as skeleton.tscn. So right. How do I? Okay, let's try to write the script for the skeleton to move, right? So let's attach a script to the skeleton. Right, as you can see, this is the default script for character body 2D, but we are not, the skeleton wouldn't jump, right? So we just, we can remove the jump velocity and the gravity and the handle of the jump. Okay, so regarding the horizontal movements, let's say, okay, let's just try to use a move and slide first, right? And we shouldn't handle the direction as well. Let's just do this. So we set the velocity equals speed, right? Equals, or say dot x equals speed. Right, so, and in the game, we put the skeleton, let's instantiate a skeleton and maybe put it somewhere in the middle of these two platforms. All right, make it a little bigger. Right, so let's see what move and slide does, right? So you can see the skeleton moves to the right and then get stuck here, right? That's because move and slide, as I mentioned in the last workshop, it handles the collision for us directly, automatically, right? So when the skeleton collide with the platform, it's just going to stop there. Okay, right. So now let's use this new function called move and collide. Right. Okay, so what's special about this function? Okay, so this move and collide function, you will need to put in an argument, which is the length of the motion. In this case, it will be velocity times delta, right? Remember that delta is our time per frame, right? So velocity times delta is the length that it should move in the frame. Okay, do I not have velocity? Oh, velocity. Okay, so we have a move and collide. And what does it do? Okay, let's try to run it. So as of now, it is similar to move and slide, right? So basically, move and collide, as long as a collision happens, then the object will stop immediately, right? And maybe I can show it like this. So if my platform is a little bit tilted, right? Okay, let's do that. So if I change back to move and slide, right? Move and slide. You can see that the skeleton should be able to climb up the ramp because it handles the collision for us, right? But if we use move and collide, then, okay, there is still some movement, but that's because it attempts to move after every frame. But by right, it should immediately stop, right? It should immediately stop when the collision happens. And we will need to handle that collision later. All right, so how do we handle the collision? We can define a variable collision equals move and slide of this, right? So that's because this move and collide function, it returns something. It returns the collision information of this movement, right? So in the case that it collides, it will return the collision information. And if it doesn't collide in this frame, then it returns null. Okay, we can try to print if collision. We can try to print the collision and see what happens, right? Okay, so yeah, you can see that it prints this kinematic collision 2D object, which contains the collision information, right? And then we can do something about the collision information to handle that collision. All right. Sorry that I have to go a bit faster this week, because yeah, we have a lot of content to cover. But if let's say you cannot follow at some point or your code doesn't work right, please feel free to interrupt anytime, right? And just discuss in the chat box as well. Okay. All right. So how do we handle this collision, right? There are a bunch of functions we can call on this collision object. It's a collision dot. You can see there are get angle, get the collider, right? What else? Get the normal, right? Get the perpendicular direction with the collision, right? There are lots of things you can do with the collision. And then after that, we can set the velocity. And then it's going to move based on the change velocity after that. Okay, so let me demo the motion just now, right? So if I turn this back, right, and okay, so now I'm going to make the skeleton turn when it hit the wall, right? So how am I going to do that? I'm going to define a variable direction. Variable direction equals 1. So here 1 means right, and -1 means left, right? So velocity x equals speed times direction. right? So let's say when the collision happens, right? Okay, first I don't consider anything. I just make it turn the direction. So how do I turn the direction? I will direction times by 1, right? Times by -1. So this will flip the sign of the direction. That means it will turn the direction, right? So after that, in the next frame, it's going to move backwards. Let's see how this works, right? You can see, right? Okay. And okay, but if let's say our player moves. So one thing to notice here is that we don't want the skeleton to always turn, right? We only want it to turn when it hits a wall, but it shouldn't turn when it hits a player, or let's say it's a ramp, right? It shouldn't turn. How do we handle that, right? That's how we can make use of the collision information we have recorded in this variable, right? So there is a collision get normal, right? Get normal. As I mentioned, this is just the perpendicular angle to the collision, right? In this case, because it's colliding with the wall, this should be horizontal, right? It should be either to the left or to the right. Okay, so we are going to check if this angle is equal to the horizontal angle, right? And the horizontal angle is just vector 2, 1, 0 or -1, 0 after it's normalized, right? So this get normal will be a normalized vector, which means its unit length is 0, which means its length is the unit length, which is 0, right? And this is the unit vector. And in fact, there is a convenient thing that we can use. So vector 2 class has this constant, which is vector 2 dot left, right? This just means the left horizontal direction. That is a normalized vector, right? So we can say that if it's either left or, okay, if the collision's normal direction is right, then we make the skeleton change direction, right? Right, so it's working the same, right? Just that we add some, we have added an additional addition to check that it is indeed hitting the wall, then it will turn the direction. Okay, everyone following so far? Okay. Okay, let me just add the same thing we did last week to change the horizontal flip of the skeleton based on the direction, right? So maybe at the start of the frame, if direction equals 1, I set the right 2D its flip H property into false. But when it's moving to the left, it should be true. Right. Right. So it's will look smarter. Our enemy will look smarter now. Okay, although not that smart, but at least a bit more smart. Maybe I can decrease the speed a little bit. Okay, right. And in the game, okay, maybe I will change the platforms a bit for today's demo, for today's final demo. So let's rotate the other platforms and then connect them together. Okay. Okay. Actually, the best way should be what? The best way should be okay, let's remove all the other platforms and then we can copy paste the original platform, right? And then we just press shift and move it to the right. Okay. Move with W, press shift and move to the right. So we can ensure that the platform aligns, right? This will ensure the platform align. Okay. Hey, oh, the first one. Oh, I only have 3 platforms. Okay, never mind. Let's create a platform for today. And maybe the player can be a bit smaller. Right. Okay. Nice. Okay, so now the platform, now the skeleton is moving and is colliding with the wall as expected, right? Okay, but you can see that we can actually play with the skeleton because we have not set any collision layers, collision masks to ensure that the player doesn't collide with the platform, with the skeleton, right? So to the skeleton, our player is a wall right now, and we need to configure that. We don't want them to collide like this, right? Okay. Okay, maybe before that, let me change the speed of the player to 400, 200, so that it's better for the new map. Okay, maybe it's better now. All right. Okay, now the thing we're gonna do is to make sure that the player and the skeleton they don't collide together. Okay, what is a collision mask? That one I'll explain. Okay, so let's click on the player node, right? And in the inspector, there is a tab called collision. Let's open that. So you can see that there is a collision layer and a collision mask, right? So I have this in my slides. Okay. So collision layer is okay. It's you can tell from its name that it just means that this object is residing on the layer, on the layer, right? And then the collision mask tells you that the current object can detect the collision with which layers, right? So if let's say my node has a collision mask of layer 1, then it is able to detect the collision with layer 1. That's it, right? So if we look at our Godot, currently our player is on layer 1 and it can detect other collision objects on layer 1, right? Let's check our platform. It is the same because we haven't done any configuration, right? All of these have default value, layer 1 and mask 1, which means that all of them can collide with each other, right? Because they can detect layer 1 and all of them are on layer 1, so they can collide with each other, right? So what we're gonna do now is to make sure that they are on different layers, right? So let's say we can set the player to be layer 1 and the enemy skeleton to be on layer 2. And we can set the platform to be on layer 3. Remember to press save. Okay. Okay. And then what we're gonna do now is that we want to make sure that the player and the skeleton can still detect the platform, right? Otherwise, they will drop through the platform. So we should set the mask of player and skeleton to be 3, right? So that they can still detect the platform, which is on layer 3. Let's see. Right, so it's working as intended. And you can see that the skeleton is no longer colliding with the player because neither the player has a mask of 2 or the skeleton has a mask of 1, right? They cannot detect each other's layer, right? Okay, the platform also don't need mask 1, right? So the platform itself doesn't need to detect the collision with the other 2. because the platform is static, right? It's there by default. It doesn't drop or anything. The thing is that because we need to ensure that these two need to detect the platform. So we have to set the mask of these two. But the mask of platform, we don't have to configure. All right, is that clear? And in fact, we can change the name of the layers, right? Let's say we can rename the layer to be layer. Just right click on the cell and then click rename. So for layer 2, we can rename to enemy, right? So for layer 3, we can rename to platform. And then when you hover over the cells, you can see the name of the layers. Let's say layer 1 is player, layer 2 is enemy. Right? When you click on this option button, you can also see a list of the layer names and which are ticked. Let's say I tick here, then yeah, the player layer is also ticked. Right. Okay. Okay. What else do I have? Right, this is just an example that we have gone through just now. Okay, maybe a fun fact of why it is called a collision mask, right? It's a bit more technical. So if you're familiar with binary numbers and binary bitwise operations, right? Actually, the layer and mask, they are represented using a binary number with several digits. Maybe it's more than 8 digits. I'm just using eight bits here. So let's say this is the first layer, the second layer. 1 means that the layer is turned on, 0 means the layer is not turned on. And this number just means that A is on layer 1 and A layer 4, right? And then this number means B can detect layer 4. B's mask has a layer 4. So when you do a AND operation on these two binary numbers, you will get this matching position that are both 1. So the result is not 0. And then Godot knows that they are going to collide. Right. So the name mask actually comes from this bitwise masking operation. This will be applied to the layer through the AND operation. Right. That's why it's called a collision mask. Okay, this is just extra information if you're interested. But anyways, let's get back to our game. Right. Where were we? We are at the skeleton, right? So, right. Now we have configured the collision layers and masks, right? Let's see if we want to deal damage to the player, how do we handle that? So currently the player and skeleton are on different layers, but we want some part of the skeleton to be able to detect the player, right? Otherwise, they will never know that they are attacking each other. So yeah, it doesn't work. So what we do now is in the skeleton node, we can add an area 2D, right? And then rename it as hitbox. Hitbox basically means the area that it can deal damage to others, right? And we need to add the collision shape. In this case, maybe a capsule, anything you like. Okay. Let's move it a bit down. Okay. Now we have a hitbox, right? Then when you select this hitbox node, you see there's another collision tab here, right? So you can configure it differently from the skeleton node. You see, let's say in this case, we want the hitbox to detect the player, right? So which mask should we set? Right. Okay, the answer is on the screen already. So mask 1 is the layer 1 is the player, so we should let it be mask layer 1. Right. So now our hitbox will be able to detect it will be able to collide with the player. But that doesn't mean that player will stop the motion of the skeleton. Because remember that the skeleton still have this setting. So the skeleton itself wouldn't collide with the player. This collision shape doesn't collide with the player, but this collision shape will collide with the player, right? So what do we do now? Okay, this is not covered yet. Well, I'll cover later, but let's go to hitbox, right? And in the node tab, there is a signals, right? So let's choose this body entered signals, right? We can right click, connect, or just double click, and then we choose a skeleton. All right, so after we have connected the signal, there will be a function that is automatically created. It's called onHitbox body entered. Okay, it basically means the event that a body enters this hitbox. Right, so let's change the function to be print. Player is damaged. Oh, how do I pull up signals again? You just click on the hitbox node, and then there's a node tab, right? This is inspector, and there's a node tab that has a signals, right? So you can right click, connect, or double click. Then you choose the skeleton node and connect. Yeah, and then this function will appear. You can see from this little green button that this signal is being connected to this function. All right. So with this, let's run our game. Okay, you can see that when the skeleton collide with the player, actually not the skeleton, but the hitbox collide with the player, this player is damaged, it's going to show. Okay. All right. Okay, so you can see that is how we handle the collision. That is how we, how do you say? We can define some events here when collision happens, right? And we can customize which collide with what, right? Which objects collide with which objects, which is amazing, right? Okay, so with all this, I have the first hands-on activity for you. Okay, so your goal is to create an orc, right? It should also be a character body 2D. It should also have a hitbox for the player, but it should not collide with a skeleton, right? Okay, and you also need to implement the player's health variable, just a variable called health in the player's code. And then make sure that the skeleton and the orc deal different damage to the player. So you can see here that when it's hit by a skeleton, the health decreased by 10 from 100 to 90. And when it's hit by an orc, it decreased by 20. Right, that's your first hands-on activity for today. Okay, everyone following so far? Right, just do the hands-on activity, and if any question, just let me know. Maybe this will take 10 minutes. Yeah. Okay. And let me know when you are ready. Just react, thumbs up when you are ready. Okay. Sorry. Let's go to the script. Okay, first question is, I don't understand the hitboxes. Right, okay, so, okay, this hitbox is an area 2D object on the skeleton, right? So, it has a different collision setting from the skeleton. And, right, because it is able to detect layer 1, right? So in the game, the hitbox actually collide with the player and it detects the player because it masks layer 1. And in our script here, okay, for now you can just think that when the body, which is the player, enters the hitbox, this will be printed. So you can see that when the hitbox collide with the player, yeah, this event happens and this is printed. Does that answer your confusion? Or which part are you not sure about? Warnings on hitbox. Do you have a collision shape 2D on the hitbox? Right. Yeah, so each of them should have a different collision shape, right? You can see here that, yeah, the hitbox itself will need a collision shape, right? Remember the node structure we talked about. The skeleton has a collision shape and a hitbox, but the hitbox itself being an area 2D, it also needs another collision shape to define the shape of the hitbox. Right? So they are independent, and the collision are also independent. Okay, maybe I need to slow down a bit. Okay, okay, regarding the skeleton script, yeah, anything unsure, just can ask. Okay, if no more questions, let's get back to the hands-on activity. Okay, let me still show the script. Maybe I can show it like this. What do I do? Okay, never mind. Okay, I just show the script first. Define variable health in player. How do I make changes? Yeah, that's a good question. How do you make changes to the health, right? So in fact, in this function, this body argument is the body that enters the hitbox, right? So you can do something to the body, like you can print body, right? You can body dot position equals, I don't know, vector 200 equals whatever, right? So anyways, you can access all the attributes of the body, can access the properties and access the functions in the body. In this case, being the player. So think about how do you change the health? Yeah. At the same time, maybe I will add some comments to the script so that it's clearer. Collision. Information. Okay. Wait, there's no player script in the GitHub? Let me check. Let me check. Oh, you couldn't launch the project of Godot. Sorry, what's the error message when you couldn't launch it? Okay, okay. How do I make the collision between player and enemy deduct health? If you define in the player.gd script. Okay, you mean that the health is inside the player.gd, right? Yeah, so you can make use of this body argument, right? So this event happens when the collision happens, which means that the player body has entered the hitbox. So then you can make use of this body argument. You can access the properties of this body, right? If the property is health, you can say body.health minus equal something, right? You can, it's a better, maybe I would say it's a better approach if you define a function inside the player. And then here you can access the function of the player, like body.function, something, right? That's my hints. Oh, this means that this file is not present in your current folder. So are you sure that your folder contains every file? As in, you open the, when you download the zip file, right, and unzip it, do you make use of, do you make use of every file in the folder? Or do you only move the project or Godot somewhere else? Make sure that every file is inside, and then you open the project.godot, right? You have every file. Right? Let's import from my downloads. Okay. Yeah, I'm able to open the zip file. Okay, just in case I download the zip file, I unzip the zip file, and then in the Godot editor, I chose import, right? And then I chose the entire folder. Right, I just copy the folder path, this path, into the launcher. Yeah, and import and edit. Okay, just try again, and you still have issues. Okay, I don't think I'm okay, yeah, okay. Okay, other questions? Oh, sorry, let me show the script. Not this one. How do I can do printfx? Oh, okay. You are referring to the string formatting in Godot, right? So the string format, the format strings in Godot is quite different from Python. You have to do like, okay, so the formatter is similar to C formatters, right? So it's percentage something. You can use the percentage S, percentage D for int, right? So I say player is damaged by percentage D health, and then you add another percentage here, and then you put the variable, let's say 10. Yeah. So this will format your string. Okay. And if you want to put multiple variables, you have to do something like uh you have to put a list. So the first one is maybe body.name, body.name, and then second one is 10. Right. So this will assign the lists, each element in the list in order into the format strings. So yeah, like that. Player is damaged by 10 health. Okay, so for those of you who have completed the hand-on, please react with something. All right. Okay, I think I will start at 8:30, right? Because we're only like 1/3 of the content for today. But for those of you who haven't completed, right, just don't worry. We can use the skeleton for the orc, right? Just anything we do later with the orc, right? You just do the same with the skeleton, right? They shouldn't matter. Oh, I should. Okay, I will just quickly do the orc. Uh, Unexpected if or the if collision, right? Okay, sure, sure. Yeah. Feel free to leave early if you have something on, and I'll upload the recording after the workshop. Yeah. Unexpected if in the class body or the collision. Uh, that. Are you sure the indentation is correct? Because Godot is similar to Python, right? So you must make sure that the space before the if is at the same level as the line before, right? Okay. Relationship D. Right. That's not relativity is a relationship. So the orc should be layer 2 and mask 3, and the hitbox should be no layer and mask 1, which is the same as the skeleton. Right. So we can actually copy the skeleton code into the orc code. So attack the script right in the skeleton. Maybe we don't do anything to the horizontal velocity, right? And the collision, just don't collect this. So the orc doesn't have anything now, right? right? So in the player, we will have a variable health, right? Maybe we can have a constant max health equals 100. And when it's ready, we can set the health to be max health, right? So in the player, we can define a function called take damage, right? And it should take in one argument, which is the amount of the damage. So what it does is to decrease the health variable by the damage amount. Okay. Or indentation. Okay. So later in the skeleton and orc, right, in this function, we can just call body dot take damage, right? So it's a good programming practice to define your constant as constants, right? Constant damage equals 10. So the body will take 10 damage, right? And in the orc, we do the same, except that the constant damage is 20. So we have a body entered. Okay. Okay. Then body dot take damage. Okay, let's test our code by adding a skeleton, adding an orc here. Larger. Okay. Oh no. And let's put it here. If we want the orc to face the left, we can just change the sprite to be facing the left. Then it's going to change in the game as well. Okay. Okay. Right, like that. Okay, right. So that's the expected code for the handle. Okay. All right. So let me introduce how do you kill the player, right? How do you make the player disappear from the game, right? So the function we use is called queue_free. So this queue_free function, right? This function basically means that, oh yeah, this current object is on a queue to be freed from the game, which means it disappears from the game, right? Then how do we use this function? We just if health is smaller or equal to 0, then the player will be queue_free. Right. So this means that when the player takes the damage and as a result the health is less than or equal to 0, then the player will be killed and disappear from the game. Right. Maybe we can, okay, we don't have to print the health. We just show. Okay, like after a few times, the player will disappear from the game. All right. Okay. So yeah, we have used this function, not this function. We have used this function in the hands-on, right? which I mentioned is the signal, and it connects to this function. So what does this mean actually? Let me show the slides. Okay, so the signals, they are just used for event detection, right? And each of the nodes, you have seen that from the inspector, you have a list of signals that you can choose, right? And these signals can be connected to the functions in other nodes, in any node you want, right? So what do I mean by connecting them? So when the specified event happens, this signal will be emitted, which means that it is triggered, right? And then all the connected functions will be called, right? As we see from our code just now, because in the hitbox, we have a signal that is connected to this function on hitbox body and entered, right? So when this event actually happens, the event referring to a body entering the hitbox, then this signal will emit and call all the connected functions, which is this one. All right, make sense? Okay, yeah, that's basically how signal works, and all the stuff inside the function block will be executed as a result of the signal, right? So this is a area 2D signal that we have used, and I will introduce another type of signal, which is a timer signal. Okay, so we have seen just now that the player can take damage very often, right? There is no interval in between the player take another damage, which isn't true in most games. Like in most games, there will be a short period of invincibility that the player no longer take damage, right? And after a few times, then the player takes damage again, right? Okay, let's implement this. So let's go to player node, right? And we add a timer in the player. So we just add a child node and then search for timer, right? This is an object. If you look at the inspector, there are some properties like the wait time. So wait time means that the time of the timer. Okay, so how long it waits before it time out, right? And then one shot means that it doesn't repeat. So if it's off, then it means it repeats itself. But if it's on, then it doesn't repeat. And auto start means that, yeah, whether it starts when it enters the game, right? So maybe we don't want it to be auto start first. All right, so we can rename the timer into, let's say, damage timer. Okay, right. Then, what do we want to do here? We want to first store the timer as a variable in our code. So the way we do that is just we define a variable timer here, right? And when it's ready, we set the timer to be this node, right? So that later we can access the timer to do some stuff. Like we can set the wait time. We can set now. We can set the timer's wait time. The property of the timer wait time to be 2 seconds, right? Let's say the player takes damage once every 2 seconds. In fact, let's do constant damage interval equals 2. And then the wait time equals damage interval. All right. Okay. And how do we use the timer? Remember the signals, right? So in the timer's signals, there is one signal called timeout, which basically emits once the timer times out. Okay, very intuitive, right? So we can connect that to our player. So you can see a new function that is called when the timer times out, and then you can do something. what's the thing we're gonna do here? We should have some properties that decides if the player can take damage or not, right? So let's just call that can take damage is true, right? This means that it's a Boolean value. That means the player can take damage, right? And in the take damage function, we need to check if the player can take damage or not. If can take damage, right? So the player can only take damage when this value is true. So remember, the thing we want to implement is right after taking damage, the player shouldn't take damage for a few seconds, right? So when this happens, we should set it to false. Can take damage equals false. All right. So the moment we detect that the player can take damage, we lock it in the sense that it can no longer take damage, and then we deal the damage, right? So the right after this, if the take damage function is called again, this will be false, so it will not take damage. All right. Then how will we implement it so that after a few seconds, this lock is removed, right? It's set to true again. Oh, scroll up to ready. Sorry. Yeah, the thing we're doing here is just to access the damage timer object, and then set the wait time to be the damage interval. Okay. Right. So, we can make use of the timer for the functionality, right? So the moment we lock this can take damage, we can start the timer. Remember, we have a timer variable, just call the start, timer.start, right? So this will start the timer, which will count the time from its wait time property, in which case we have set to be 2 seconds. Okay. So after 2 seconds, this signal will be triggered, and we can do something here. Got it? Which is to set the can take damage to be true. Right. Can you see the logic? Right. Let's see how this works. Okay. Oh no, it doesn't work. Okay, never mind. There's something wrong with my code. It can take damage. Oh, I never start the timer. I'm sorry. But that doesn't. Oh no, I started the timer, but sorry. Yeah, let me see what went wrong. Take damage is true. Okay. will be under player. Right, you are right, you are right. Okay. Yeah, you are right. Okay, so even this is being printed, right? It doesn't mean our player is taking damage because this is printed when the hitbox detects the collision, right? So we should move this into our player, right? So only when the player is taking damage, we should print that player is damaged by this damage health, right? Then this will work. Okay, yeah. Now it is printing only when the player actually takes the damage, right? Thank you. Right. You can see our timer is working as expected. Okay, everyone is able to do the timer. All right. Okay, so here is just a list of frequently used signals, right? For area 2D, you can detect when a body or an area is entered, has just entered, or has just exited. Yeah. For timer, you can detect the timeout, right? And for a button, you can detect when the button is being pressed, right? Then you do something. Yeah. And by the way, you can also implement your own custom signals. Right? If in the future you want to implement some weird signals, you can just search and check from the Godot implementation, right? So basically, you just create a signal, a custom signal class, and then you define the event. After some event, you make the signal emit. There's an emit function from the signal, which will call all the functions connected to the signal. Okay, okay. So let's practice a bit. Right. So let's get some timers so that our orcs can jump at random intervals. Play some orcs, and then each of them should jump independently. Okay, so for those of you who haven't implemented the orc, right, you can just do it to the skeleton, right? Just make the skeletons jump at random intervals. Yeah. And to implement random, right, you can use this function. What's the function? Rand something, right? You can use randf. Randf is a random float, which is a random decimal value, right? So randf, right? And then, or you can use a randi, which is random integer, right? Then you can also use randi range. Maybe this one is the easiest. So you can randi range from, let's say, 2 to 4. And this will take a random number from 2 to 4. So 2, 3, 4, each with equal probability. Right. Okay, let's try the practice. Maybe this will take 5 minutes. Yeah. Okay, I think for the interest of time, right, I will just do the practice on my computer. Right. So try not to refer to my demo, but if you are feeling confused, you can refer to my demo. Right. So yeah. Okay. Okay, can you show some reaction if you are ready? Okay, let's continue. So I'll go through the how to set up the timers, right? So in our org node, we just add a jump timer, right? And same as the player, we can access the jump timer to store it in this variable, right? So the most essential thing is that we have this function. We can call it start jump timer, right? So what this function do is to set a random duration and configure the wait time of the jump timer to be the duration, and then we start the jump timer. And when the jump timer times out, we can make the orc jump by setting its vertical velocity. And then we call the start jump timer again, right? It's a recursive call to the start jump timer function, which will again set a different random time and then start the timer. All right. Yeah, and also just remember to add the gravity so that the fork can jump. After it jumps, it can land. Right. All right, so let me add more orcs to the game. And you'll be able to see that they will jump at independent random intervals. Okay, right. So let's continue. Okay, maybe we don't have time to finish everything, and I'll just cover the third part first. So this part, I will talk about how do you access other nodes from your current node, right? So the first skill we want to learn is how do you instantiate another object, right? Remember that currently we create our child objects with this instantiate child scene, right? So if we want to add an orc, we just instantiate child scene and choose the orc scene. So we can actually do it programmatically in the code. Right. The way we do that, okay, let's actually for this purpose, we need to create a new scene, which is the arrow scene. right? So yeah, let's just create an arrow scene. Let's change the type to be area 2D, right? You may wonder, why do we choose an area 2D for the arrow, right? It's you can think about it. Yeah, it's a design option. Why do we choose an area 2D for the arrow, right? So as usual, we will add a sprite 2D and a collision shape. Yeah, let's zoom in a bit, and we can choose a rectangle for the arrow. Okay, and regarding the collision layer, right? We want the arrow to not to have any layer and to mask the enemy layer, right? So that the arrow will be able to hit the enemies, right? Because it's an area 2D, right? So it's able to detect the enemies entering the arrow and then do something to the enemies. Okay, right. So the reason we want to create this arrow scene is to demonstrate how do you instantiate an arrow in the player, right? We'll be able to create an arrow from the player script, right? So instantiate basically means you create an object of the scene that you have defined. Right? How do we do that? We can define a constant. Let's call it arrow. We use this function called preload. Okay. And then we can drag our arrow scene from our file system, to drag it into our code, right? So this will be the path to the arrow scene. And what preload does is it packs the entire scene, right? So it creates a scene object and it's stored in the constant. And then this packed scene, right? We can call an instantiate method to create an object, right? So maybe to illustrate, right? We can do something in the physics process. So in each physics process, we can define a variable, small letter arrow, right? Is equal to the big arrow dot instantiate, right? So this just means you create an object from the packed scene, which is the arrow, right? Let's see. Okay, so this only creates the object and assign it to the arrow, and we will need to add it to the game, right? How do we add an object to the game? We can use this add child arrow, right? This will add the arrow as a child of the player, but that's actually not what we want, because we don't want the arrow to belong to the player, right? If that's the case, then they will share the position. Then wherever the player moves, the arrow will have the same position. We should add the arrow to the game instead of the player. And how do we access the game? We have this get parent function. Basically, this gets the parent of the current node, right? Which is the game. So the game has a player as a child, then the parent of the player is the game. And then in the code, we get the parent first. So this get parent will return us the game object. And we add a child to the game object, which is the arrow object. And then the arrow will appear in the game as a child of the game. Does that make sense? Okay, let's see how it works. Oh, it's not. Oh, I know why. Because we never set the position of the arrow. Right, so we need to set, we have only created an arrow and added to the game, but we haven't set any property of the arrow, right? Maybe we want the position of the arrow to be the same as the position of the player for now. How we do that is just arrow.position equals position, right? So this will create the arrow object first, and then set its position to be the same position as the players. We will expect the arrows to be spawned at the player, right, in each frame. Yeah, it's just for now we implement like this, but you can see how the object is being created and added to the game, right? Okay. Okay. Maybe to make it less wonky, right? We can do some inputs. So only when the input is pressed, then we create the arrow, right? Remember how do we create an input? We can go to project settings, input map, right? And then maybe I want to add an input that is the mouse click. So I will add a new action that is UI mouse click, right? And then we can add the event, which is the left mouse button. Yeah, feel free to use any other input. Yeah, it's just to illustrate that you can also detect a mouse input, right? So in each frame, if, remember how do we detect input? So if input dot is action just pressed, UI mouse click, then we do this. Okay. So now one arrow will be added at the position on every mouse click. Okay. All right. Okay. Okay, now you may say, it sucks that the arrow stays there, right, in the air, right? So maybe we want the arrow to shoot. So we should do that in the arrow script. Let's add a script to the arrow. For now, let's say we want the arrow to shoot to the right. So we should define a direction that points to the right. So it should be a vector two as 1, 0. And we can give it a speed equals 10. And then in each physics process, it's going to move by the direction times speed. So for area 2D, we need to set the position. Position will increase by direction times speed times time. Right. Not time times delta. right? Oh, okay, it's moving, but it's very slow. Okay, but it's moving, yeah. We should increase the speed a bit. Okay. Let's increase the speed to, let's say, 200. Okay. Okay, is everyone able to do this? Create an arrow object each time some input happens, right? All right. Okay. Now, don't know if we have time, but let me just introduce how do you set the direction of the arrow, as you guys have seen in the demo, right? So we'll be using this function called we'll be using a function to get the mouse position, right? And then we can determine the direction of the arrow. Okay, so where is the arrow? Okay, it's in the player script, right? Maybe we should add a new function. We just call it shoot arrow, right? Shoot arrow. Then when the left mouse is clicked, we call the shoot arrow. And we move all the logic inside that function. That's cleaner. Okay, so all we're gonna do here is to set the arrow's direction to be something, right? And what should that direction be? It should be pointing to the mouse, the position of the mouse, right? We need to get the position of the mouse. Let's say var mouse position equals, we can just use this Godot function, which is get global mouse position. Now, this global here just, there's a global position and there is a local position, right? This gets the global position in the entire game, but not in the local position of the scene, right? This is just a minor detail, right? Okay. And with the mouse position, we can calculate the vector that represents the direction of the arrow. Var shoot direction is, okay, it's pointing from the player to the mouse position. Thus, the direction vector should be mouse position minus position. Yeah, it's a vector 2D minus vector 2D. So the result shoot direction is still vector 2D. Okay, and then we can set the direction of the arrow to the shoot direction. And in the meantime, we may also want to rotate the arrow a bit, right? Otherwise, it will look very strange. It will be a horizontal arrow moving at a non-horizontal direction. So we can set the arrow dot rotation. And feel free to calculate the angle if you want to practice your math. But there's a function in Godot. So we have the shoot direction, right? Shoot direction is a vector 2D, and then we can get angle. Yeah, we can just call the angle function and calculate the angle of the vector corresponding to the horizontal starting position. Right? We can, yeah, we just assign the angle to the rotation of the arrow. Let's see how this works. Oh no, apparently it doesn't work. Wait, something's wrong. Let me see. Yeah. Yeah. Oh, I see, I see. I see why. Okay. So that's because we never normalize the direction, right? The direction should be normalized. There is a function, there's a function of vector 2D, right? That is normalized. As you have learned in your high school math, it will normalize the vector into a unit vector of length 1, right? Then we can set the direction. Just now, the arrow is created, but because I never normalize the direction, right? Then in the arrow script, this direction is very large. So the speed is damn high so that we cannot see the arrow, right? That's why. So make sure you normalize your vector and assign it to the direction. Okay. Right. Okay. Now the arrows will be created according to our mouse click. Okay. This is the code. Make sure you can follow until this point. Okay. Is everyone following so far? Give me some reaction, please. Okay. Okay. Nice. Okay. Now we have defined how do we shoot the arrow, right? Now we can make the arrow kill the enemies, which is the same thing we did before, right? Because arrow is an area 2D, then we can have this signal that is body enter, right? We can connect this signal, right? And we make sure to kill the enemies when it enters the arrow, right? Well, because when you shoot the arrow to the enemy, you can imagine that the enemy body is entering the arrow area, right? So that's why this signal will be triggered. But if we only add this, right? Okay, so if we don't differentiate the body between other objects, there may be some bugs, right? Let's say the arrow can collide with the platform, and then we kill the body. That means we kill the platform. Right? It shouldn't happen because we set the mask to be layer 2, but we can just be safe and check the body. Right? If body if the body is an enemy, we can kill the enemy, right? So how do we check the body is an enemy? So for now, the only way we can do is to check the collision layer, right? If it's on layer 2, then we know that it's an enemy. But in the future, I will introduce other ways that is more powerful to check if it's an enemy or not. Maybe we don't have time for this workshop. So for now, let's just check body dot get collision layer. Yes. Is there a get collision layer value or something? Oh yeah, let me check. Yeah, get collision layer value. So this function takes in two arguments. The first argument is the layer. Right. And then the second argument, wait, does it? Oh yeah. Sorry, let me check. Okay, sorry. This one also only takes in one argument, which is a layer number, right? And then it returns if this collision layer is turned on or not, right? So it just takes in this layer 2, and then so this means that if the body's collision layer contains a layer 2, then we can kill the body, which is body.q3. Right. So that means when I collide with an enemy, then the enemy will be killed. Right. You can also define other stuffs. Yeah. Anything you want, like let's say the arrow should disappear once it hit an enemy, right? So you also Q3 the arrow. All right. And then maybe for now, when the arrow hits the platform, the arrow should also disappear, right? The way we do that is just to make the arrow mask layer 3, which is the platform layer, right? And then here, edit body.get collision layer value is 3. Then we only Q3 the arrow. Okay. Yeah. Okay. All right. Okay. So that's pretty much about how do you access other nodes, right? I mean, yeah, mainly it's about how do you instantiate a scene into an object and you add it to the game, right? And also here's just some functions that you can use to traverse the entire tree of the game. So get node just means you get the child, you get the layer below the current node, right? We have seen that when we drag, let's say the sprite into the code, then it's this $sign with the name of the node. This is just a shorthand for get node name, right? Which gets the node, yeah, by the name. You can also use this get child, get children, right? So get children returns you a list of all the nodes under the current node, right? And get child by index is in the list return which one. Right? So get child 0 will return you the first item in the list, etc., etc. Yeah, these are I just put this here so you can explore later. Yeah, and this is how you traverse up the tree. You can get the parent, or you can get the top of the tree. Right? You just get the entire tree and then do some stuff. Okay, we have 3 minutes left. Yeah, so maybe if you have time after the workshop, you can try this. Hands-on. So basically, yeah, as you saw in the demo, right? The arrow should stay on the platform. If it hits the platform, it should pause there, and it should no longer kill the enemies and it disappear after a while. I think this is a good practice to sum up everything we have learned today. Okay, right? And regarding the groups, maybe I will cover them in the next workshop. Yeah, next week when we meet physically. Okay, and yeah, feel free to check these slides. And if you have time, you can do the challenge of the week, right? Now we have all the skills to make our game fun, make our game playable, right? You have all the ways to configure your complicated logic to create a to handle those events as you wish, right? Yeah, you can define anything you can. Now you can think of ideas. How do you make your game more fun? Like these are the ideas I have lah. Like if you land on the head of the skeleton, you should be able to squash it to kill it, right? But if you if you collide with the skeleton from the side, then it kills you, right? That kind of ideas, right? You can make the orc throw stuff at you and damage you, or you can make the armor reflect the arrows, right? Which will damage you, right? All these kind of ideas that you should have the skills to implement all these ideas. Okay, so yeah, this is the end of today's workshop. We have looked at the first three ways that we can make our game playable, right? We can add logic to our game and make it playable. And in the upcoming week, right, we can make our game enjoyable by adding all these fun elements into our game. So right now, all the sprites are static, right? They are not moving. Like the sprite looks like a static picture, right? But I will show you how do you animate those sprites. How do you do some custom animations when some events happen, right? We can also code the UI to provide information for the user, right? And maybe the camera background, and then add some sound effects and BGM to our game, which will surely benefit your game and make the player enjoy it. Yeah, so that's pretty much more about this week's workshop. Sorry for cramming all these contents, right? But I mean, yeah, I hope it was physical because now you have to refer to my demo and then refer to your code at the same time, right? But if it's physical, we should go faster. Yeah. So yeah, all right, that's all. So yeah, see you next week. Thank you. Thank you. See you.